Hello everyone. In this tutorial we will see how to create some very simple web shooting and swinging system. I also have some other courses in the link in the description. For example, this one is called the drawing robot. We'll create a fully procedural drawing slider robot that can draw any vector illustration or Houdini curves. So if you are interested in something very unconventional and very interesting, you can buy that. Let's dive into the tutorial. Let's put on a file and I have downloaded a spider model. I'll give the link in the description. I got it from TurboSquid. First thing is I'm going to extract one point, and that point is where the web will be shot from. So I'm just going to select somewhere here and group. I'm going to call it emit pt. I'm going to increase the scale 3 times. So I'm going to do the simulation in a bigger scale. And I'm going to rotate it to fit it in a wall. I'm going to put a grid and just rotate it by -90 and just increase the scale. And I'm going to call this, where we are working on the spider system. So I'm just going to place the spider somewhere here in the wall, and that's it. Now I'm going to extract only that point that we selected, the emission point, emit pt and non-selected. So we got this point. Now we need to decide where the spider will jump. I'm just going to template the spider. So somewhere around here I'm going to create the collision, or where the spider web will attach it to. Just put down a box and I'm just going to place it somewhere over here. And increase the scale, something like this. And one thing I'm going to do is I'm going to keep only these two faces. I don't want the point to be formed somewhere here and the web to struggle to pass through the collider. I'm just going to keep these two sides. So in the left side I have a point, but in the right side I have some polygons. I'm going to create a subnet. So we are going to use a modular system kind of modules to build the system. So the first input I'm going to queue the source point, and the second input I'm going to queue the collision geometry. First of all, I'm going to name it web system, and I'm going to create a variable here. It will be a float. I'm going to call it the start frame. So this is the frame the web shooting will start. Start frame. For now, we are going to come and change this later. So here I'm going to ghost. Yeah, we have one point. I'm just going to disconnect it and put it somewhere else, and I'm going to put down a scatter, and to the right input I'm going to scatter one point. So we have a point here. I'm going to merge these two. So we have 2 points here. One is the emission and one is the target. I'm going to create a line in between these two using add prim 0th input. polyline is the kind of line that we need, and we need point number 0 and point number 1. We have 2 points, so this will create a line. Create line, and then so we need to animate this line from 0 to 1, but we need to do the animation timing based on the distance. Okay, so first let's calculate the distance. Effort distance is equal to distance. We need two positions actually. We'll call it P1, P2. We don't have it yet, so let's create them. Vector P1 is the position of the 0th point. So from the 0th input, we are extracting the position and the 0 point number. Now we'll do the same for the first point number also. Vector P1. Okay, P2. Yeah, I'm going to change this to technical. I like this viewport. I can directly visualize the geometric spreadsheet from here. And we have the distance attribute. It is something 55 meter. And now based on this distance, we are going to create some other attributes. The first one is animate. So this is the time taken for the animation of this curve to start and end. Okay, so we will do this one based on the distance, and if it is 0 to 1000 meter, so that is like 1 kilometer, we'll keep a value like 1,90 maybe. So this value looked fine for me, but you can check for your own setup, and I think this value should work for most of the setup. So if the distance is 0, we are going to have a animate timing of 1, else we are going to have somewhere in between 1 and 90, but this will give us a float value. So we will just put down a seal to select the higher integer. Okay, so even if it is 5.1, it will select sits if you use seal, and then we'll create an attribute called start frame. And this start frame will copy from here, copy parameter and paste relative reference. So this is the actual frame when the web shooting will start. Then we'll calculate end frame is equal to, so if we add the start frame plus the animate time, we'll get the end frame. Start frame plus f at animate. Now let's check this out. Start frame, for example, if it is 0, and animate, if we have sits, 0 plus sits, it's is sits, will give you a start frame 30 for the first one. So now start frame is sits, the animate time is sits, sorry, start frame is 30, the animate time is sits, and so we have the end frame 36. Now we'll create an attribute that runs from 0 to 1 between 30 and 36. F at anim time, we'll call it, is equal to fit. We are going to use the frame number, f at start time, comma f at end time. So we are going to fit this value between 0, comma 1. So now we have a value that will run from 0 to 1 between the start frame and the start frame and end frame. This is wrong. Yeah. Now let's see the anim time. So 30 starts animating, and by 36 it becomes 1 because the animate time is 6. Now we'll promote all of this to detail attribute, attribute promote, and we'll promote all the necessary attributes to detail. Animate, anim time, I don't want the distance, so end frame and the start frame. Okay, I'm going to call it out attrib, or I'm just going to call it attrib. So this last 3 nodes I'm going to keep it aside, and I'm going to carve the curve. So the first U I'm going to keep it at 0, but I'm going to animate the second U from 0 to 1. So this will give us the animation, and this value we'll take it from the attribute that we created, attrib anim time. If you remember, anim time is the attribute that runs from 0 to 1. And now we have the animation of the curve. At 36, it becomes fully animated. Okay, we'll resample it, and I'm going to use maximum segment length of 1. So 1 meter distance, there will be 1 point. So by using this distance to, the length, even if your point is like very far away, it should still work, and our dynamics should still be the same. Okay, now we need to switch between this carve, the animation, to the resampled one by using a switch. And for this we'll use the end frame. So starting we need the animation, then we'll shift it to resampled because we are going to use the resampled version for the simulation. Okay, we'll access the end frame. So $f greater than or equal to this value, end frame. Okay, now let's see, we have only 2 points now. We have the animation, but once we complete the animation, it automatically shifts to resampled one. Okay, so we need the first point and the last point separately. We need it in a group. We'll just create that. We'll call it first and last group. So the first point will be with point number 0 always. Okay, we did a mistake. You see, like there are multiple points overlapped within the same point. That is because this create line, we are running out points. So we have 2 points, so it is going to run over every point. We are going to change it to detail. Now we have only 1 line. So if I at pt num equals 0, I at group, we'll call it 0 is equal to 1. If I at pt num equals n points, 0 minus 1. So n points will give the number of points, but point numbers start from 0, so minus 1. We'll call it I at group attach, because this is the point that we are going to use to attach. Okay, is equal to 1. Now let's put down a Vellum string or Vellum constraints and change it to string. This damping ratio, I'm going to change it to 0.6. So you can adjust this value according to like how you want the rope to behave. So this is the only change that I'm going to do here, and then I'm going to put down an attached geometry, and in the third input we need to give the attached geometry, the geometry to attach to. So whatever comes out of the second input is what we are going to use for attaching. Okay, we'll call it to attach, and we'll copy and merge it here. And we are going to use only the attach point. Yeah. So now only the attach point will get attached to the wall that we created. And here also I'm not going to change anything. But you can also play with this breaking threshold to have some interesting simulation. Let's put on a Vellum solver. And in the force, we'll reduce this built-in wind drag to very bare minimum. And the simulation start time, we are going to again start at the end frame. Okay. So when the full animation is done, then we are going to start the simulation. Now let's play and see. It doesn't work. Something is wrong. The end frame is showing 0. But end frame is 36 here. Okay, I made a mistake. It should be double quotation. Yeah, now let's play. We have a simple rope simulation. I'm going to increase the frame range to like 500, 5 something. So now we have a very basic simulation. Now we need to shift from this animation to the simulation. Again, we'll use a switch node. We can just copy the same switch node and connect the second input to the Vellum solver and the first one to the previous switch. Yeah, we have the rope simulation working properly. And first starting, if you see, we have the animation, and then we shift to the simulation. So if you remember, from the 0th input, I mean the first input, we are inputting the emit point, and from the second input we are inputting the collision. The same we will output. Okay, this output 0 will bring it, and so from here we'll delete the 0th point. So we need only the 0th point. Okay, so that will be the 0th output, and the curve will be the third output, because second input we are giving the collision. Okay, so we'll create another output just for dummy purpose, so that we get one more output here, and we'll create another output, and here we will output the curve. That's it. Now we have all that we want, I think. Now we can start building the system. So to create more webs, you just have to copy and connect the first input to the first input, and the third input to the third input. But the second input, we will create another collision. From here we can look at the curve, and let's see when we can connect to the next curve. So somewhere here we can shift to the next one. I'm just going to copy these two, and I am going to shift it to the right side somewhere here, and I'm going to input it into the second input. Okay, and the frame number is 142. Remember to change the frame number for each and everything. Now let's see what is happening. there is some issue, and also we are having the new curve, but the old curve is not coming out from here. So there is some issue. If you see, the curve starts forming, but then something happens and it disappears and then it comes again. There is something weird happening. So we'll make our changes here in the last web system that we copied. So this is because if you see, the distance keeps on changing. Okay, so because of this, the start frame and the end frame are also going to change. See, now the end frame is like 153, before it was 154. So that is not correct. What we are going to do is, we are going to put down a time shift just before the attrib, and I'm going to come out and copy the start frame. Remember to copy the start frame from outside, because from here we cannot access the start frame, because we cannot access it from the previous node. So just paste relative reference. But we are having an issue. We have one attribute called anim time. It runs from 0 to 1. If you disable, you can see it is like running from 0 to 1. But if you enable the time shift, it is not going to animate. So we'll just copy the same thing again, but without the time shift. We'll call it attrib anim. Okay, and only the carve node we will access from attrib anim, and remaining everything will access from this time shifted. And now let's see if it is working properly. Yeah, it is working properly. So, but one thing is, we are not seeing the previous web. That is because we are not merging the input with the output. I'm just going to object merge and merge the previous input to this second output, and we are supposed to get the web from the third input. We'll call it web, and I'm just going to merge it out. So if you remember, third input, we are getting the web. Okay, now if you see, we can play both, and we have the animation happening. That's it. So now let's delete the first web system, because both are same. We should have uniform system, and paste it again, and let's connect them all together again. And this is the old connector, the previous one, and the start frame is 30. We'll again check if everything works fine. So we should have same module, and we just keep on connecting and create as many web system, as many spider web as we want. Okay, now it works perfectly. But if you notice, you can see that there is no velocity transfer between the previous curve and the current curve. Imagine there is a spider attached here, and it is going to shift from the first curve to the second curve. It is going to take some of its velocity or the momentum along with it to the second curve. Okay, we can easily fix this. We'll do the changes in the latest one. If you remember, we are getting the point, the previous 0th point from the first input out. We'll call it well, and here I'm going to put down an attribute triangle just before inputting it to the solver, and object merge that point and connect it to the second input. V is equal to point first input position and zeroth point. We are only going to have 1 point. Okay, but this is going to give the velocity only on the first frame. We need to Also, one more thing is we need to run it only on the 0th point. Okay, only for that 0th point we are going to give this velocity. One more thing I'm going to do is I'm going to increase the mass by 20 times. This is because our spider is going to be hanging there, so we need to fake the weight by increasing the mass. Okay, let's come in and we'll do some things here. First, I'm going to put down a geometry wrangle and connect it to the force, and I'm going to import this this velocity point over here. I need to import it to the second. Sometimes this is the second, sometimes I'm confused, so I'm going to import it to the both of these. It doesn't matter, and I'm going to access it. V at V is equal to point. From second input we are getting the velocity, and we are going to have only 1 point. But now it is continuously going to take the velocity. Now if you see, the second curve is keep on going to follow the first curve, and we are applying it to all the points. But the velocity, we are going to slowly fade away the previous curve's velocity. So lerp from this one to the current velocity, we are going to use a value called blend. Let's create this value, float blend. So once the simulation starts, this value will start running from 1 to 0, sorry, 0 to 1, fit at frame. So based on the frame, and let's come out and take the simulation frame, not the start frame. So the simulation frame, simulation start frame, and paste relative reference. Actually we'll create a channel. It's not allowing us to paste the relative reference inside the wrangle. I'll just call it start time, comma, so start time plus 1. So from the next frame we'll start blending, not the immediate frame. Then we'll blend it for like maybe 4 frames. So 4th frame it'll go back to its original velocity. It is no more taking the velocity from the previous curve. Okay, and we are going to fit between 0 and 1. Now the start frame we are going to paste a relative reference, and that's it. Now let's play and see. Actually we are not going to apply the velocity to all the points, just to the 0th point we'll try. Now let's see. Yeah, you can see the velocity is like being transferred from the first curve to the second curve. I think we have some viewport issue. Yeah, we can see the velocity is like being transferred properly from the first input to the second input. I mean from the first curve to the second curve. So this is the updated system that we have. I just color code it. We can later copy it to the first input also. Now what I'm going to do is I'm going to attach the spider to the end, and we need to shift the spider also. The spider should be picked up by the first curve, and then it will shift the spider, it will transfer the spider to the second one, and how much ever we attach, it should happen automatically. Okay, so what we will do, we will So this is the output. We are getting the curve. From this we can blast the point 0 and delete non-selected. So we are getting that 0th point alone. Now I'm going to object merge the spider. So this transform will copy again and will not have any translate or anything. We need it in the origin, so we'll make the translate to 0 and we'll keep only the scale, and the rotation will make it 0, everything else will make it 0, and we'll put down a null spider model, but the scale will keep it the same. Now let's object merge here and copy 2 points. But by default there's going to be some p scale here in the Vellum solver, the Vellum. So I'm just going to delete the p scale. I'm just going to delete everything except the normal. Okay, normal we are going to create if it is not there. Yeah, but you can see we have multiple points, 0th point here. So every curve is going to have 1 0 point. We'll just put down another blast, but this time we'll delete the 0th point number and delete non-selected. Okay, so this 0th point number is always going to be from the latest curve, but we'll merge the curve along the spider. The spider's orientation, it's not going to change at all. You see, it is static. So we are going to find out some way to orient this based on the source, and again like we are going to smooth out the normal. So let's come to this latest web system, and in here we are going to calculate the normal, but this normal will calculate only for this point, but it is going to be based on this point minus this point, the centroid point, and to this point. So first we are going to subtract the center position with this position. We are going to get one normal. Then this position, the last position with the center position, we are going to get one normal. So if you add these two, we are going to get kind of like an average. You'll see what I mean. We'll get the position of all three. First we need the point number. Int 0th point, or we'll call it lower point. This point is equal to, that is going to be 0, and int midpoint will create n points 0 minus 1. So this will give the last point, and we are going to divide it by 2 and convert it into an integer, divided by 2. Actually we'll put a bracket here also. I think sometimes it is going to consider 1 by 2, I'm not sure. So n points 0 minus 1 divided by 2, and we are going to call it MP, midpoint. Okay, and now we'll calculate the last one. Int, we'll call it UP, upper point, is equal to n points 0 minus 1. So that will be the last point. Now we'll extract the position for all three. Vector position, we'll call it position lower, is equal to 0.0, and the point number is LP. Vector position mid is equal to 0.0, and we'll get the position MP. vector position u upper point 0 position up, the upper point. Okay, now we'll create two vectors. First we are going to subtract this one with this one and the top one to this one. We'll call it vector 1 is equal to, so mid minus lower. Okay, pm minus pl, and the second one the top minus the mid. Vector 2 is equal to pu minus pm. Now we'll add these two and we'll get the kind of the vector that we are looking for. V at n is equal to 1 plus 2 semicolon. So only for the second curve we have created that. And let's check if it is right and if it does have some value. Normals, yeah, it is there. Actually we'll normalize this. These two vectors. Now let's come out and see if the spider is attached to the properly. Okay, but you can see there is a change in the orientation. Like the orientation is being calculated from these two. Now we will change the transform here and rotate it to place it properly. 90, yeah. So this is how the spider should be attached. So looks like the orientation is working, but yeah, I'm just going to copy this web system to the first one also. I'm just going to delete and replace the inputs. And the start frame is 30 for the first one. Now let's play. Okay, it is working. But if you see, there is a sudden shift in the direction, the orientation. So we can avoid this by using chops. I'm going to put down a channel just below the attribute triangle, and above it I'm going to put to smooth, and the attribute scope is normals and the method is animated. I'm going to put down a chop network and select it here, and inside the chop network I'm going to put down a geometry node and select that to smooth node. I think the node name is okay, to smooth node, and animated normal. Put down a filter and out. So this should smooth the normal change. Let's see how it looks. But if you use chops, it is going to cache the entire timeline first, and only then it is going to perform the smoothing. So let's see what is happening. Yeah, now we can see the spider is like carried given to the other string, like and it is smoothly transitioning. Yeah. So we have done the spider setup. Now we can add some more lines, like some more webs. So somewhere around here, 270, yeah, 266, I'm going to create another web. Copy, connect the first input to the first input, third input to the third input, and for the second input we are going to create new colliders. Let me check, where is my curve? It's here. So I'm going to push it more here, and see, this is going to be a bit longer, and I'm going to connect it to the second input, and the frame start will be 266. Let's select all these and now connect it to the second input, I mean third input. Let's see what happened. We have the first curve, second one, and the third one. Yeah, so I think it should work with unlimited curves. Now let's visualize it with the spider. Okay, if you notice, the length of the string is keep on getting increased. So here I'm going to put down constraint properties, Vellum constraint properties, and first of all I'm going to come to the string and turn on this output group. So we get a group for this properties to access this properties, and I'm going to access the stretch, and the rest length scale I'm going to animate. So fit at frame. So again the same thing that we got here, the start frame. So this start frame is from the simulation, so we'll use that, +1. So after the start frame, to maybe like +8, we will reduce the resistance scale from 1 to 0.7. Okay, so this will mean that the curve is going to shrink. I'm just going to copy that note to all the systems. Yeah, so this one will give the a little pull to the spider, and it will pull the spider towards the source. So this will also prevent the curve from becoming too large too soon. Yeah, yeah, I think it works. So you can create as many webs as you want using the system, like you just copy and paste. But if you want, I think maybe after like 7 or 8 8 curves you can cache, then again you can continue. So if you're caching, you can cache all three separately, or you can put one groups to each and every one of the input, and then I mean only two inputs, and then cache and split it again. So that's up to you. Another one thing I totally forgot. If you see, the currently the string is attached to the geometric center or the bounding path center of the spider, but we need to attach the string to the emission point. If you remember, we have a separate group here, And I think here we are not getting that group, so we'll just create an attribute I at emit is equal to 1 and only for that emit pt. Let's blast that point. Only the so at emit is equal to 1 and delete non-selected and point. So we got that single point. And attribute triangle. Connect this to the second input and connect this single point to the third input. We will calculate the difference between these two positions. V at diff is equal to the second point minus the third point, 0.1 position 0 minus 0.2 position 0. And now let's connect the copy to points, the spider to the first input. And let's also visualize the string v at p plus is equal to v at diff. I think it is minus, yeah. Now you can see the string is attached to the correct point. Also, I made an error. So I wrote it as mass into 20, but it is actually mass into equals 20. So change this in everything. And also one more change I am doing. I just want to leave the string properties to you. I decrease the damping ratio to 0.3. So I present some other courses also. For example, this is like very interesting thing, a fully automatic procedural drawing robot. It will take any vector illustration or even curves like from Houdini curves or vector illustrations, and then it will draw it, and it will draw using this method, like it is kind of a drawing slider robot. So if you are looking for something very interesting from my side and also like very unconventional, you can check out this tutorial. Thank you.